Okay. The flocculation is part of the pre-treatment. So when you look at the program, pre-treatment is day 4. At the day 4, I actually brought some samples. What is most popular pre-treatment filtration aid that you know of? Huh? What did you say? Candle filter. A candle filter. The pre-treatment, well, we're gonna go over day 4 anyway. So I'm not gonna go. Here, you already seen that the water. So if you use the flocculant agent, then it clear out the water quickly. So the raw water here, once you use the coagulation agent or flocculate, then it happens, agglomerate particles. You can actually remove it by sedimentation. This is the essence of pre-treatment process, solid liquid filtration and separation, particularly in water and wastewater treatment, mining, food processing, and chemical manufacturing. So efficiency, sedimentation, flotation, filtration, aggregating the fine suspended and colloid particle into larger, so making agglomerate and each separate by sedimentation process. This is kind of schematics. Particle surface charge. You have to use the coagulant, the agent, add it. Then it's more likely a coalescing phenomena. It's same concept. The coagulant making big particles so that you can easily eliminate the microflux. So every time when I have the slide, that is the source right there. So if you like to understand in deep detail, then use source. Okay? I wrote everywhere. Some of them are research paper. Then it's tough because I select the important part from the research, the journal. But like this one is not research journal, so you can go through it in order to understand better. The colloidal micelles are closely related to coagulant flocculation and processing in wastewater. Neutralization, coagulation, flocculation. So some particle is negatively charged, and if you use some agent, and then it create the bundles, coagulant, coagulation, flocculation. In fact, the coagulation, flocculation, I'm not really sure why they separate. It's most likely a similar kind of phenomena. I'm going to ask, what's the difference between coagulant and flocculation? Anyone?
Making the molecules bigger, neutralizing and making the molecule bigger. And flocculant, I think there is another particle. I'm not too sure that they help them come together and make a macromolecule.
We're making bigger molecules, that's for sure, but I don't know the difference. Actually, you can, I have to look it up. I can find out. Because I have chemist background, so somehow you have to look at the what's different. I can find out. That's my homework. So block diagram primary water treatment plan with DAF technology. We already covered that one. Feed water cause slur separation and fine, and you have to use coagulant. See, any dewater one, wastewater, you got to use coagulant. So sedimentation velocity is really fast.
What is the role of sodium hypochlorite there?
What?
Sodium hypochlorite in water management after feedwater. NaOCl. So after feedwater there is NaOCl. Chlorine. Just on the left there is a feedwater, and after that there is NaOCl.
Emphasis. Oh,
Chlorine hypochlorite. Sodium hypochlorite.
Sodium hydrochloride. Yes, that is correct. Yes.
Yeah.
Ah.
I think that is neutralizing agent. Most wastewater are
Well, that's really a good question, which I don't have answer. So,
I think most of the wastewater they are in acidic in nature, and just to neutralize that, we are using this.
It's a neutralization agent. Neutralization agent. You are correct. He has answered, but I didn't pay attention to it. But anyway, the source is there. The source is there. So if you have a question, you look at the source, then you can get the answer from that. Here, the liquid filtration is not a small area. It's huge area. There is no way you can get all the information that you have. So even myself, if it is related to the diesel engine area, I can tell what is right, what is wrong. Some of the area is really tough. It is really huge area, liquid area. The air filter is a bit smaller than liquid, not a bit, it's a lot smaller than the total liquid filtration area. No, you have to use a flocculant. Wastewater and water treatment, you have to use flocculant. That's the first step of doing it. Coagulation. neutralize electrically charged particles. Well, that's good. That cause them to repel each other, remain dispersed in the suspension. The coagulant, typically salt, like aluminum sulfate, ferric chloride, are added. These coagulants relate positively charged ions and stabilize the negatively charged particles. These stabilized particles begin to clump together, microflux. The common coagulant, inorganic, Al2SO43, alum, and ferric chloride, ferric sulfide. Organic one, polyamide, and what is flocculant? Flocculant, after coagulation, gentle mixing is applied to encourage the collision and bonding between the particles. Flocculant often is high molecular weight polymer. That's the difference. The other one is inorganic material. It's coagulant. And flocculant is polymeric material. That's different. Wow. Yeah.
She has found that coagulation, chemical process, flocculation, physical.
Oh, physical process.
Coagulants are added, so there is a chemical reaction. Here polymers are added, only increase the size of the particle. So no chemical.
Wow, that's a good answer. Yeah, that's a good answer. That is really great. Good answer. Yeah. Yeah. If you like to learn something, then I normally suggest you to teach. And then you can learn a lot like that. The answer is right there. Physical state or chemical state, chemical reaction state. That's big difference. La, la, la. Here, flocculation, all the material right here is polymeric material. So it's a physical nature. It's a physical nature. But previous one is the all inorganic material, which is chemical reaction. So, like I told you earlier, I love teaching, but I hate evaluation. In US, that's big part of it. In US, I don't know whether it works in India. I doubt it. I know. And so I told you earlier, nowadays chemical engineering field, there are more women than men. Yeah, in US, long time ago, you cannot see any female student in the chemical engineering field. Nowadays, more than 60%. So looks like my habit is look at all the pretty woman, pretty lady only. I didn't actually notice it when I read the process evaluation sheet. You always look at the prettiest woman. You never look at me. So the public speech, important thing is eye contact. Eye contact to everyone. But I did have some issues. Only look at the pretty one. Everyone. But the girls, they are quiet. sensitive. I did not know. But I always got that kind of the comment through. Anyway, the after coagulation, flocculation, sedimentation, classification, filtration, and dewatering. The application, drinking water treatment, wastewater, and mining, mineral processing, and for the beverage, the key consideration, pH also, pH is quite important. The dosage optimization critical to prevent overdosing. The mixing condition must be controlled. It's kind of the busy slide. The coagulant, aluminum sulfate, ferric chloride, polyaluminum, all of them are actually, if you look at the flocculant, it's organic material, polyacrylamide, and the flocculant, another one, and starch-based biopolymer. There is 8, bentonite clay, and chitosan is there too. So one of the flocculant, chitosan, that's the natural material, natural polymer. Currently, the chitosan is quite popular material because it's a natural polymer. So sustainable material, we always talk about chitosan. The advantage and mechanism of reaction, actions. I believe this is a really good table for choosing right flocculant and coagulant itself. Polyaluminum chloride, this is more expensive than aluminum. Chitosan, expensive, less stable than synthetic alternative. Chitosan is expensive? Anyone knows? Chitosan is expensive? Huh? Oh, really? Ah. Yeah. Yeah, if it is a medical application, it certainly is expensive. Certainly the starch-based the biopolymer, that's another important one currently because it's biodegradable substance. So both of them are quite popular. However, it's less effective than synthetic flocculant. Let's see, it's cosmetic for industry. This is another trouble. All of the natural material or biodegradable material, the effectiveness is not as good as the man-made, the polymer and other synthetic materials. Well, you already seen that, the pictures. The use of covalent or flocculant enhance the rate. Of course, we already knew that. Well, this is quite important, the principle, zero potential. So if zero potential is big, probably everyone knows zero potential. Do you or not? That is called the stun layer. Right there, stun layer. So the negatively charged particle, then there is the positive the charged solution. It has some sort of the boundary layer. So they call it stun layer. And then it's dilute it's a mixture of the positive and negative charged the effluence around there. So zeta potential is this one. We call it zeta potential. See, this morning I noticed one thing. The AFS, the American Filtration Separation Society, we have short course. However, that short course is not as extensive as this one. Especially Dr. Mukhopadhyay, he knows a lot about the media itself on the filtration application. He is really expert. But the American Filtration and Separation Society, I don't know, maybe we can find something. But currently, we don't have class like this format. So I believe this course, I believe you are really lucky to be here. Because in America, we do not have course like this, extensively like that. Also, I noticed that in American Filtration and Separation Society, I never heard of MBR process, something like that. Because somebody need to pay attention to it and create something. The zeta potential, it has been around for a long time, importance of it. Why it is important? So the higher zeta potential, the greater the electrostatic repulsive force, less tendency for particles to get together. So you need to make something really lower the zeta potential. So in order to make the agglomerate. That's why zeta potential is important. Coagulation. Stability of colloid the particles. That's stable and unstable. So you have to make unstable. So at the large zero potential value, which is minus 40 millivolt, will make the system very stable. Then coagulation is not occur very well. So coagulation means destabilize colloid system by charging the electrolyte concentrate, reduce the zeta potential. Well, try to reduce zeta potential. the coagulant lysis is all inorganic material, especially Fe, Al, Fe, and Ca. I don't know whether we have the, maybe later. The compound used are ferric sulfate and ferrous sulfate, aluminum chloride, aluminum sulfate, aluminum. Selection of proper coagulant is based on experience and test. The coagulant is the kinetically the second order process. Coagulant rate depends on the square of solid concentration. It's slow and dilute suspension like potable water treatment. Sequence of coagulants needed. Ionic concentration suspended. Somehow you have to reduce the zero potential in order to make the overlay. That's the conclusion. How you can destabilize some natural polyelectrolyte effective flocculant. So flocculant, natural flocculant, starch, gelatin, pure gums, and polyacrylamide. We actually talk about a lot something previously. Polymers are characterized by average molecular weight. The high molecular weight, 20 times 10. This is really high. This is polymer. Medium size still is high. Low molecular weight still it looks to me 10 to the 6 power. That's really polymeric material. It's a long chain actually, molecules. So disperse of flocculant into water solution. And transport flocculant in solid liquid surface. I don't know whether I have to read everything. Whenever I say you can read a lot faster than I do. Why don't you read through it? Huh? Yeah. I don't want to spend a lot of time to read it. So probably if you need this information, then you can go through it. So this is the experimental setup, coagulation. So same agitation level, but you can see which one is the coagulate fast. So I don't have this setup. This setup from Dow Chemical. Dow Chemical. They have exactly like that. The procedures, how you can operate that setup. Also, TSC test is really commonly used for the flocculation and coagulation. The setup is right there, but you have to use the here, right? The timer, how you set it up, and slurry, and filter paper down here. This is the actual measuring devices. CST test is quite popular in the laboratory when you do the flocculation and coagulation research. The procedure of CST. What is the CST right there? Capillary suction time. Capillary suction time test. So 20 seconds is considered fast filtration. 120 is CST test result. This is interesting one. So the coagulant, this one. When you look at the chemical chart, coagulant is around this area. This is same thing, same as the one you saw it, but it's a little bit different setup. The one that I showed you, that was the in the Dow Chemical company. This was, you can actually set it up like this. So decantation ability ratio and time, when you look at the different coagulant, then you'll see the decantation ability ratio much better with the aluminum flux than FeCl3 flux. The sludge treatment. I got this data from the Korean research, is Hanyang University data. You can actually look at the size of the agglomerate. So it's a TiO2 process. They use a TiO2 as flocculant. So they keep saying that the TiO2, use the TiO2 as the flocculant. Oh, okay. I think that's the end of my slide. The pre-treatment. I brought some samples. So day 4, you can look at the samples itself. I didn't bring a lot, only 2 or 3 cc's of samples, so you can actually look at the filter A. I still have the jet lag issue a little bit. I don't know whether it's my age related or not. I hope not. But anyway, I like to conclude the flocculation class because this is the last slide. So if you don't have any other questions or something like that, we can start lunch a little bit earlier. I don't know what time is it.
Yeah, it's almost just 5 more. Okay.
We have 10 more minutes then. See, I have the Fitbit watch. I brought it here. I tried to synchronize to my cell phone. It didn't work here. I don't know what happened to it. If someone can help me to synchronize, it'll be wonderful. But still, without it, still I can manage. That's why I don't have words. The
She will help you to get connect work with the phone.
Really? Really?
We can try, sir. We can try. We will try.
Okay, then I'm going to bring it tomorrow. The fit is really good because I'm runner. Yeah, so when I run, it has every information down here. Also, you can use this one. However, it's a little bit heavy. Also, my sexy pants. I don't, I don't, I'm not used to carry. Also, the pocket is not big enough.
I would suggest you to use a boot pant. That's better than bit.
Okay, I have to turn it off.